Hello, welcome to Office Developer Patterns and Practices core training. My name is Anton Mislevich. I am a senior consultant working for Microsoft Consulting Services, and in this module we will talk about remote time job framework. As you are going through this course, I believe you already know what Office Dev PnP is and why should you care. So I will not spend much time on introductions. And here is our plan for this module. We first briefly discuss timer jobs and remote operations in SharePoint. Then we look at how PnP call library can help you implementing your custom timer jobs. And finally, we talk a bit about Microsoft Azure and why it is good to deploy your timer jobs to Azure platform. With this, let's get started. First, let's do a quick recap on timer jobs and remote operations in SharePoint. Timer jobs are remote, asynchronous, long-running operations in SharePoint. There is a number of out-of-the-box timer jobs which you can monitor and manage by going into SharePoint Central Administration portal. It is also possible to develop your own custom timer jobs. In order to do this, you need to create a class that inherits from SP job definition, provide your custom implementation, and deploy it as a full trust code DLL on SharePoint servers. As a result, your timer job will be available on the single list with out-of-the-box ones. Many of our customers have developed their own custom timer jobs this way, and this is why when I have discussions on migrating existing customizations from full trust code to Cloud Add-in model, usually customers are asking, okay Anton, but what shall we do with our custom timer jobs? These are deployed as full trust code solutions, and there is no way to implement timer jobs via Cloud Add-in model. I recommend them to take a look at remote timer job pattern from Office Dev PnP. Here is how it works. You have a SharePoint environment where all your sites, data, and functionality is hosted. Then you have a remote environment to run provider-hosted apps. Remote timer job is a component that is deployed on external environment. It runs on some schedule, connects to SharePoint via client-side object model, and performs needed operations this way. The next question I usually get is, okay, it looks interesting, but what is the key differences of this approach from regular timer jobs? Let's take a look. Here is what regular timer job gives you. First, it has scope that defines what sites to run the timer job against. Then it has a schedule that defines when to run it. Next, it has a host that defines on which machines in the farm will your code run. Finally, there is authentication that defines what are the credentials with which the code is executed. Let's take a closer look at these four aspects. Here we have a comparison table, timer jobs, remote timer jobs, and four aspects we've introduced before: scope, schedule, host, and authentication. Now let's go through them one by one and see what are the differences. Scope. Regular timer jobs can be scoped to a specific web application or the entire farm. Remote timer jobs can be targeted to specific site collections. You can also use wildcards to include all site collections that match specific naming pattern. I will show you this later in a demo. Schedule. For regular timer jobs, schedule is configured via central administration. For remote timer jobs, scheduling can be done using any mechanism on hosting environment. For example, you can use Azure Web Jobs or regular Windows Scheduler. Host. Regular timer jobs run on servers in SharePoint Farm. Remote timer jobs can be executed on any remote environment, as Azure or Windows Server. And finally, authentication. Regular timer jobs run with credentials of the farm account. You can obviously also do impersonation in the code if needed. For remote timer jobs, you can create specific service account and run the code with credentials of this account, or you can use app-only tokens. We will look into both of these options later in more detail. As you can see, remote timer jobs give you even more options comparing to regular timer jobs, and this is why our customers are successfully using them to implement various business scenarios. Good examples here are governance-related tasks, some regular maintenance tasks, or implementing fallback for remote event receivers. As you perhaps already know, for remote event receivers, we do not have guaranteed delivery. This means that if some event occurs, SharePoint sends a call to your remote web service, and if the service cannot be reached, SharePoint will not try to resend this call later. This is why you need to implement a fallback logic, and this is where remote timer jobs can help. The final concern you might have is performance. I get asked this a lot as well. If the code runs outside of SharePoint, does this mean that performance of remote timer jobs is lower comparing to regular timer jobs? This is correct, but I would add few more considerations to this. First, there are already hundreds of native timer jobs running on SharePoint servers. This means that your timer job has to compete for resources with other native and custom timer jobs. And I've seen customers spending a lot of time adjusting schedules in order to avoid conflicts among timer jobs. The second thing is that for me, performance and scalability usually come hand in hand. If you are concerned about performance, you should be concerned about scalability as well. What happens when your timer job needs more hardware resources? The problem with regular timer jobs is that if you want to scale out, you have to add additional SharePoint server to the farm. With remote timer jobs, you don't have these two issues. Your timer job runs on dedicated hardware, so it is not competing with anyone, and scaling should not be a problem as well. You can use built-in Azure capabilities, or if you run your code on premises, you just need to add another Windows server. This is much easier. Finally, timer jobs by definition are long-running and asynchronous. So slight drop in performance because of remote execution model should not be an issue. Now, let's see how PnP call library can help you to implement remote timer jobs. This is how the process looks like. You create new Visual Studio project, add NuGet package for PnP core component, then you create a new class inheriting from timer job base class, and you write your custom code here. After this, you need to configure authentication, create a service account, or register the app and grant app-only permissions. Then you specify the list of site collections on which the timer job should be executed, and finally, you deploy and run the timer job. Let me show you this process in a simple demo. Here we are in Visual Studio environment, and I'll go and create a new project. Let's select console application and type a name Hello World Timer Job. The first thing we should do is adding a reference to Office Dev PnP NuGet package. Let's go to Add References, search for Office Dev PnP. And here you have two versions, one for on-premises and one for SharePoint Online. Let's pick the one for SharePoint Online. Let's accept license agreements. And now you can see that the package is installed, and in references, all new references to Microsoft SharePoint Client and to Office Dev PnP Core are successfully added. The next thing what we need to do is add a new class that will implement our timer job. Add new class, let's call it Hello World Timer Job. Add. We first need to make it public, and then we need to inherit from timer job class. Let's resolve naming here, add using statement. Now let's add a default constructor, Hello World Timer Job constructor, that uses base constructor and specifies the name of the timer job. And here we specify the method that provides actual implementation of the timer job, what the timer job will be doing. Let's implement the method. We don't do anything complicated here, we just connect to the web object, get a title and write it out. We write URL and title of the web. Let's add using statements. Office Dev PnP core, obviously, and another thing what we need to use is Microsoft SharePoint client for sure. Let's try to build the solution. It built successfully, and now let's go back to program CS. And in program CS, first let's add a helper method that will help us to generate secure password. Resolve. And now in the main method, first let's type out some message that the application is running and that the application is done. And finally, let's instantiate our timer job. Hello world timer job. Job is new. Hello world timer job. Let's add authentication. We will use Office 365 authentication for this sample, and I will be using my development tenant. And now let's add a scope. So on which sites will this timer job run? Add site. And for the add site method, for this demo I have created a bunch of sites already. Here they are. The URL is like this, antonsamdev.sharepoint.com sites dev, and we also have dev1, dev2 and dev3, and on dev site we also have some subsites. Let me go back to Visual Studio and just paste in this URL. Here it is. And then what we need to do, we just need to say job run. And let's execute the code. You can see the timer job was executed. We were able to connect to the site, and here is the name, the title of the web. Now let's try using wildcards. If I add a star here, this will mean that now the timer job will run on all site collections where URL matches this pattern. Let's execute the code. And as you can see, here are all site collections, dev2, dev3, dev4, just dev, dev5 and dev1. You can see that these are not in alphabetical order. This happens because by default timer job is executed in multi-threaded fashion. Here, if you may set a parameter use threading to false, and in this case the timer job will be executed in a single thread. If you want to run multi-threaded, you can also set a value for parameter maximum threads, and this is how you may define how many parallel threads do you want to have. Let's rerun the code without multi-threading, and you should see that the sites are now being processed in alphabetical order. And also you may see that execution now takes longer because we're doing it in a single thread. The last thing I want to show you is expand subsites property. By default it's false, but if you set it to true, the timer job will run not only on site collections, but on every subsite inside site collection. Let's rerun the code. And what we see here is that for dev site collection we have subsites web1, web2, web3, and all of these now have been processed by our timer job. As you could also see from the demo, here are some benefits what you get from PnP Time Job framework. Authentication is easily configurable. You can dynamically specify the list of site collections to be processed. The time job runs on site collection level. You can optionally run it on every subsite as well. We have a built-in configurable multi-threaded execution model. We also have a state management. This means that the time job can store additional information in property bags of site collections. So when it processes specific site collection, it knows when was the last time when this site collection was processed and what was the execution result. Development experience is pretty easy, and we also have built-in logging capabilities. Let's take a closer look at authentication. With remote time jobs, you have two options: using specific accounts or app-only tokens. Using specific accounts is similar to classic service account model in on-premises. You have to create a new account, configure required permissions, and then remote time job uses login and password of this account to access SharePoint environment. With app-only tokens, you need to register app ID and secret for remote time job application, grant permissions to this app. This can be done on the entire tenant or specific site collections. Then you usually put app ID and secret in app config, and remote time job uses these to access SharePoint environment. Please note that not all functionalities work with app-only tokens, so you might need to use specific accounts for some operations. Wildcards inside URLs is one example here, and I'll talk about this in the next slide. Let's take a closer look at dynamic scopes. The framework allows you to add site URLs to time jobs dynamically. You can also remove URLs that have already been added. And as you have seen from the demo, you can also use expand subsites property to process not only site collections, but all subwebs. Finally, you can use wildcards inside URLs. As in this example, the time job will process all site collections under site's managed path. Please note that this does not work with app-only authentication. So if your time job uses app-only authentication, you have to provide so-called enumeration account, what will be used to find all matching sites. I will show you this in the next demo. Time for a demo. Let me show you a good example of a real remote time job. For this demo, I will be using Core Time Jobs sample solution from Office Dev PnP. Here we have many samples of time jobs, and the one I will be showing you here is sample 5, governance job. What this job does: let's jump straight to the code and take a look at implementation. Basically, we get the list of administrators for specific web, and then if there are less than 2 administrators, we mark this site as incompliant, and we add a GS link, so visitor of the site will see a notification bar showing that the site is non-compliant, and potentially it may have, for example, a link to instructions on how to fix it. What is interesting about this sample also is that we are using state management. For time job, we set a manage state property to true, and as a result of this, when the time job is executed, we store JSON serialized state information in a web property. The name is timeJobName underscore properties, and the information we store there, for example, is last run date, timejob version, which was it, and if execution was successful or not. In addition, I've also created few sites on which we can test this time job. Here is the URL: govtest, govtest1, and govtest2. Let me copy this URL for govtest2, and let's jump to Visual Studio. Here is the project, and here is the implementation of our timer job. So basically the same code I was showing you in a web browser. And interesting that this get administrators, for example, is Office Dev PnP core extension method. So you can see that we are using these extension methods in our code extensively. add.jslink is extension method as well. Here is the JavaScript file which contains all logic for the notification bar, what users will see. We actually upload this JavaScript file into the style library. Now, what we should do. So first I've copied the URL of the site. Let's go back to program CS and paste the URL here. So this is all familiar stuff for you already. We create a new instance of site governance job. Then we use app-only authentication, and for this we need to provide client ID and client secret. We will do it right now. And then in order to use wildcards, we need to set credentials for enumeration account. Set enumeration credentials. For this we need to have username and passwords, because otherwise we cannot use wildcards here in site URLs. Now, what we need to do, we need to register our application so it has permissions on the site. Let's go back to Internet Explorer, and what I'll do first, I'll go to Layouts 15 Up Reg New. I'll generate new client ID and new client secret. The name of the timer job will be governance timer job. Let's put some URL and some redirect URL. Let's create. And now here is the information. Here we have client ID and client secret. I'll copy this. Now let's go back to Visual Studio. And in Visual Studio, we need to go to app config. Here you see we have username and password for enumeration account already. And here we will put our client ID and secret. This is our client ID. This is our secret. And finally, what we need to do, we need to grant this app permissions on our SharePoint environment. Let me go back to Internet Browser, and here I'll go to appinf ESPX. I'll paste application ID, press lookup. This is our application, and what I'll do, I'll put XML here that grants this app permissions to run with app only, and also I'll grant permissions to the entire tenant, and this will be full control permissions. So this app will have permissions to access all site collections inside the tenant. I'll trust this application. And now the application is registered. So as we are in GovTest2 site, let's go to Site Collection Administrators. We can see that here we have only one administrator. So this site is not compliant. Let's go back to Visual Studio and let's run the code. You could see that this site is not compliant. We can go back here, and if we go to the welcome page of our site, we should see this information bar. Your site is not following company policies. 2 or more administrators are needed. Click here to learn more. I'll go back to site settings, and I'll go to Site Collection Administrators and add additional administrator here. So now we have 2 administrators, and this means that the next time when the timer job will run, let me start it with Ctrl F5 so the window is not closed. we will see that our site now is compliant. And what this means is that when we go back to the site and I press refresh, this notification bar is not here now because the site has two administrators. Let's go back to Visual Studio, and here what I will do, I will replace these two with a wildcard. So as a result of this timer job will now process not only one site collection, but all three site collections what we have. Control F5 again. And now you can see that our GovTest2 site is compliant. It has two administrators, but other two sites are marked as incompliant because only one administrator is there. Now, let's talk a bit about Microsoft Azure. There are several options how you can host your remote timer jobs. For SharePoint on-premises, you can just deploy executable file and use built-in Windows scheduler to run it on a regular basis. Or you can build your own Windows service that runs timer jobs. For SharePoint Online, you can use web jobs in Azure website, or you can use any of the on-premises options. Let me show you how to deploy a remote timer job to Azure. We are back in Visual Studio environment, and now let's publish our governance job to Azure. To do this, I right-click on the project and select Publish as Azure Web Job. Then I need to provide the name of the job, and then I can select how the job should run. Should it run continuously or on specific schedule or on demand? For this demo, I'll select continuously. For real production deployments, you usually want to specify a schedule, how you want your job to run, and now I click OK. Now let's select a target where the web job will be published. I select Microsoft Azure Web Application, New Web Application, let's use the same name, create new app service plan, create new resource group, and let's host it in North Europe. Create. Now I click Publish, and we can see that web app was published successfully to this URL. Now let's go into the web browser. Here we are in Microsoft Azure Management Portal. Let's refresh this view, and we should see new web application available. Here it is. Let's open it up. And in settings, if we scroll down, we see web jobs. Let's open it up. We see our web job deployed. It's executed continuously. And here is a link to see logs. And now you can see that our timer job is not working because it cannot load some assemblies. What we need to do, we need to go back to Visual Studio. And now in Visual Studio, we need to make sure that all referred assemblies are actually copied locally. So let me select these assemblies, copy local, let's set it to true. And Microsoft SharePoint client assemblies are already set to true. Office Dev PnP core as well. Now let's republish the project. It was published successfully. Let's go back to the web browser and refresh the log. Now you can see that our timer job is running. And here is the log with similar output what we've seen in a console window. So GovTest2 is compliant, GovTest1 marked as incompliant, and GovTest is marked as incompliant. Here are our sites, GovTest. Let's refresh it. You can see that notification bar is here. We are not following company policies. 2 or more administrators are needed. Let's go to site settings, site collection administrators. Let's add second administrator here. And let's do the same for GovTest1 site, site settings, site collection administrators, and let's add another administrator here. Now all our sites should be fixed. Let's go back to the log of our web job. Let's refresh the log. And now you can see our timer job was executed once again, and now all of our sites are compliant. And if I go back to the home page of each site, I should not see this notification bar anymore. This is true for this site, GovTest1. It's true for this site as well, and GovTest2 was compliant. As you could see from the demo, deploying remote timer jobs to Azure is really straightforward. Now, one final topic I would want to discuss. You can actually use the same remote timer job pattern for asynchronous tasks. This would allow you to ensure that UI is responsive and fast, and long-running operations are not affected by web request timeouts. It is really easy to implement this in Azure using storage queues and web jobs. Let's take a look at how this works. You have SharePoint, provider-hosted app, which is a web application, storage queue, and web job. User clicks on a link in SharePoint site and is redirected to a web page in a provider-hosted app. Then he fills in some form and clicks Submit button. The web page puts a message in the storage queue and immediately returns response to end user saying that the request is being processed, so we will not get a timeout here. Then a web job picks a message from the queue and performs needed actions. Good real-life example of such solution is site provisioning. You request new site, fill in required metadata, and then the site is being created. Creating the site potentially can take some time, so it is wise doing it asynchronously and not in a web request thread. Here are some links to additional resources on Office Dev PnP Timer Job Framework. I encourage you to go and look through these after completing this module. With this, I hope you are now ready to build your own remote timer jobs. Let's keep in touch via various Office Dev PnP communication channels, and thank you very much for your time.